For this part, right, this is one of the main fundamental things between EMATH and AMATH. Okay, so this is what we'll call something called complete square. So you'll hear complete square in EMATH, you'll hear complete square in AMATH. So what exactly is complete square? So first of all, right, you need to know what is the general format of a quadratic equation. So if you look at the general format of a quadratic equation, you should see that it's very organized. It's organized in terms of ax squared, bx, and then a constant. So this is called the general form. So that means the numbers are arranged at x squared, x, and a constant. So a is known as the coefficient of x squared. And b is the coefficient of x. C is the constant term. So this is a standardization in the general format of a quadratic equation. So A is the coefficient of x squared, B is the coefficient of x, and C is a constant. So actually, A has an important job to do. So A is the indication whether your quadratic will become a smile graph or a sad graph. So we will be talking about the sketch of quadratic function in the next section. So anyway, at the moment, you just need to know that A has an important job to do. A will decide the shape of the quadratic function. Okay, so we're going to be changing the format to something called a complete square. So if you look at the complete square, there is also a A. So it is the same thing. A is the coefficient of x squared. But the difference is, right, in the complete square form, right, you will recognize that there's a bracket. There's a bracket square. So actually, this is the complete square. So something square is known as a completed square. So this part, right, is where we get a complete square. This is a perfect square. So we'll be changing the format. And then from the general form, it becomes a complete square form. So in a complete square form, you will find that there's a bracket square that is known as a perfect square. And then there is also a number behind the perfect square. So the perfect square comes from the idea that you learn in Sec 2. So all these are called perfect square. So these are the perfect square that you learn in Sec 2. So we will be using it here. Okay, so you think about it like changing clothes. So you are changing the clothes of a quadratic equation. So it's like, you wear different clothes and you look different. So in this case, we are changing the clothes. Okay, and why are we changing the clothes? Because, right, it will be helping us to find the minimum or the maximum y value. So in a way, right, it will tell us the lowest y value or the highest y value of the function. So later on in the second part, in another part, right, you will be learning the sketch. So you will be seeing like, okay, this is the lowest y, and then this one is the highest y. So that is the purpose of why we need to do a complete square. And it is also useful because we need the turning point. The turning point is this. So the turning point is also what we'll call the lowest coordinate or the highest coordinate. So the reason why you need to do a perfect square, you need to change the general format to a complete square is to get the highest value or the lowest value. And it also tells us the turning point, that where is the coordinate of the lowest point or where the coordinate of the highest point. And then lastly, we will be solving the quadratic equation by the complete square method. So you already learned how to solve quadratic by factorization. And you also learn how to solve quadratic by the quadratic formula, the huge quadratic formula. So sometimes you'll be asked to solve quadratic equation by the complete square method. So these are the few reasons why we are changing the general form to complete square form. And there is a steps that we would like to follow. Okay, so I'm going to briefly run through the steps, and later on there'll be some numerical example to illustrate the steps. So first of all, right, step 1 is one of the more critical. So you need to ensure that the coefficient of x squared is 1. So the coefficient, so the value of a is 1. So you need to make sure the coefficient of x squared is 1. You need to make sure that a is 1. If it's not 1, right, you need to factorize out. Okay, so later on this part, we will talk about it. But this is one of the most important. If you miss out this part, the whole thing will be wrong. Your whole complete square is totally wrong. Second part, you got to identify the value of b, which is what we'll call the coefficient of x. So you will be introducing this thing here. You will be adding and you'll be subtracting. So it is like a formula. So you'll be adding and subtracting after the second term. Okay, after that, the first 3 terms becomes a complete square. So the first 3 terms will become a complete square. Later on, I'll explain more on this part. And the last 2 terms will be punched from the calculator. Okay, and then there will be a square brackets. So the fourth step is to open up the square bracket. So why would there be a square bracket? If you will need to factorize out a, then you will have the square bracket. So how good with you with complete square depends on how well you can follow the 4 steps. Okay, so before I show you a numerical example, okay, look at the general format of a quadratic equation and look at the complete square format of a quadratic equation. So what can you see? What is the difference? So in the complete square form, you'll find that there's a bracket with a square. Okay, and that is what we call a perfect square. And what are the 3 purposes that you actually need to change your complete square? And these are the steps that we actually use to change a general form to a complete square. Okay, so I'm going to show you a numerical example. So the first numerical example, okay, so first thing, so recognize that this is a squared plus bx plus c. So you should be able to recognize that that's actually a general form. So I'm going to change to a complete square form. So I'm going to change to the complete square form by following the steps. So the first step, I need to ensure that a is 1. So can you see that a is really a 1? You compare, you will realize that a is 1. Okay, after you realize that a is 1, okay, second step is you need to identify b. So if you look, this is your b. This is your b. And in the second steps, you are supposed to introduce this. So you are supposed to introduce this after the second term. That means you're supposed to add in b over 2 square minus b over 2 square after the second term. So kind of like you are adding in something. So I'm going to add in the b over 2 square. And I'm going to subtract the b over 2 square. So maybe you're thinking, why am I adding and I'm subtracting? So do you realize that I'm adding and I'm subtracting the same thing? So essentially, it is a value 0. So I didn't disrupt the balance of the original quadratic equation. So I added something that's actually a 0. Okay, but why am I doing that? So I'm actually doing it so that this part can become a completed square. So this part will actually become a complete square. So how does it actually become a complete square, right? So let's think about your Sec2 expansion. So this part, can you go and punch calculator? If you punch calculator, you will get something like this. So this part, if you do the factorization, you will get something like this. So that's exactly why I said that in the third step. So in the third step, the first three terms became a nice completed square. So the first three terms becomes a nice completed square. So this is the B. So this part is actually the B over 2. So that's how my completed square come from. So you added in something and you add in something so that you can do a nice factorization to become a perfect square. Okay, but we cannot add in something and then it's like, oh, the value is like when you add in something, the equation is exploded. So I actually got to subtract something. Okay, so here I add and I subtract at the same time. Okay, so this is the part that a lot of people didn't get used to. So in lower side, you don't see such thing. You don't have this idea that we need to add in and we subtract at the same time. Okay, so we add in and we subtract the same thing so as not to disrupt the balance of the original equation. Okay, so this whole thing you can punch from the calculator. So if you punch successfully, right, you will get a -1. So if you look at the first step, I make sure that A is 1, the coefficient of x squared is 1. After that, I go and check out for my B. So B is a -4. So look carefully. So look carefully that you can identify your B as a -4. Okay, and then you are going to add in B over 2 square minus B over 2 square. So the idea of adding in, okay, allow you to factorize. So after you add in, the first three numbers is actually being factorized. The first three numbers. And then the last two numbers, no need to do anything, just punch calculator. So that is the technical process. That's the technical process, how we do a complete square, how the 4 steps are being used for the complete square. So then, how do we use it? So eventually, right, this part is the minimum value. So this is the y coordinate. So in this case, right, this is a minimum graph. Okay, this one is a small graph. When A is positive, it will be small. So this is the lowest value. So the lowest value, the lowest y value will be a -1. And then, right, this one, mentally, you let it be 0. That will be the x coordinate. Okay, so after this, right, you can actually get you can visualize where you will be having a small graph. So 2 -1. So this is where you're going to get a small graph. So the lowest value is -1. So we talk about the sketch later, but right now you must be able to see that it actually gives you a small graph. The lowest will be at a value of -1. And the turning point will be, this is called the turning point. The lowest point is also called the turning point. So this is the coordinate where you make a smile face. So this will be one of the two purposes that we actually need to do a complete square. Okay, then how are we going to solve the complete if I want to solve the quadratic equation by the complete square method? So this whole thing will be changed to the completed square format. So this whole thing will be changed to the completed square format. So don't go and expand out. you bring the number over. Then you do a taking of square roots. So when you take square root, there are two possible answers. So you will have x minus 2 equal to 1, or you will have x minus 2 equal to minus 1. So these are my two answers. So can you see I make use of the complete square form? And then I bring the number over so I can take a double square root. Okay, compare to this one. Okay, I'm quite sure if let's say you can do it by the factorization method. So if you have done it by the factorization method, so if you've done it by the factorization method, you will still get the same answer. Or if you have done it by the quadratic equation method, quadratic formula method. So if you've done it by the formula method, do you still remember the huge formula? So if you try doing the huge formula, you should also get the same answer. So you shouldn't have a difference in answer. (16 minus 12) will be a 4. So I will get a 4 plus 2 over 2. I will get a 4 minus 2 over 2. So I will still be getting the same answer. Okay, so can you see the same equation? I can do it by the factorization method, provided it's factorizable. So in this case, it's factorizable. I can also do it by the quadratic formula method. So this is the complete square method. The answer is still the same, but the methods are different. So there's no reason why you will have a different answer if you are dealing with the same equation. So all the different methods should still lead you to the same answer, no matter what method you use. So when do you need to pay attention to the method? The question will tell you. The question will say, like in this case, it's a hence. If you express it as a complete square already, you see the word hence. That means you got to do it by the complete square method. If the question says you're supposed to use the quadratic formula, okay, then go ahead, use the quadratic formula. Okay, if the question says you do it by the factorization method, then this part is the factorization method. So during O-level, they actually specify you the method. During exam, they also specify you. The only time when you are free to do any method is when they never specify. If they say solve the equation, plainly solve the equation, then you just do it by the way that you like most. So most people, for me, I like the quadratic formula. There are some people who like the complete square method. So complete square is not so easy. You need to get the hang of the steps. Okay, and then you need to make sure you got no callus. There's a lot of possible callus. So one of the possible callus is the identification of B. So B is supposed, so where is the possible mistake, right? Like for example, in this case, B is a minus 4. But some students, they never see the minus. Okay, so they didn't see the minus. They thought that B is 4. So that is a careless mistake. So another thing is the calculator portion, the part where they got to press calculator. So some also press calculator wrongly. So if you find that you are full of careless mistake for complete square, you really need to work your way to ensure 100% accuracy. Okay, so this is a sample example of how you change a general form to a complete square form, and why are we doing this, and how are we doing this. Okay, so take a look at the generic idea.